Every time you sit down for a meal, you perform a routine, almost thoughtless action. You take a bite, chew, and swallow. This simple swallow initiates a sequence of automated responses across 30 feet of internal anatomy. This diagram shows the scale of the route, a gauntlet of mechanical pressure and chemical baths designed to break down matter on a molecular level. Digestion is a 36-hour engineering task. It is a precise mechanical disassembly line required to convert raw matter into the fuel that keeps your cells alive. The intake valve is your mouth, where raw mechanical force takes over. Your teeth act as the first line of processing, tearing solid matter into smaller, manageable fragments. As you chew, your salivary glands inject chemical pretreatments into the mix. This fluid immediately begins breaking down carbohydrates, softening the material so it can be moved deeper into the tract. Looking at this volume comparison, you can see the surprising output of that fluid production. In a single year, a human produces enough saliva to fill 2 medium-sized bathtubs. Past the mouth, the tract splits. To prevent food from slipping toward the lungs, the body triggers a cough, a violent expulsion that forces the material back into the correct channel. Muscles in the esophagus walls execute a rhythmic sequence, contracting behind the food and relaxing in front, a process called peristalsis. That squeezing forces the mass down until it hits a one-way valve that opens to let material through, then snaps shut to prevent reversing. Because of this active pumping mechanism, the upper tract operates independent of gravity. It functions as a secure mechanical chute, locking raw material into the chemical processing centers below. The material arrives in the stomach, a highly durable muscular sac that actively expands to accommodate the incoming mass. The environment inside is corrosive. The walls secrete hydrochloric acid, creating a pool that dismantles the chemical bonds holding the food together. Through a combination of heavy muscular grinding and acidic soaking, solid fragments are dismantled. The stomach reduces solid chunks of food into a uniform biological slurry. The stomach strips away all recognizable form from what you've eaten. Its primary function is to transform a meal into a raw biological paste ready for nutrient extraction. From there, the slurry is pumped into the small intestine, a coiled, snake-like organ divided into 3 distinct processing sections. This graphic illustrates a surprising metric. If you were to uncoil the small intestine and pull it straight, it would measure over 20 feet long, reaching the height of a fully grown giraffe. As the paste travels this tube, accessory organs join the effort. The liver, gallbladder, and pancreas act as secondary units, injecting bile and enzymes. These chemicals dissolve complex fats and extract vital nutrients, routing them through the intestinal walls into the bloodstream. Once the small intestine finishes its work, the nutrient-depleted paste enters the final leg of the journey, the 5 to 6 foot muscular tube known as the large intestine, or colon. Inside the colon, the environment completely shifts. The material enters a dense swarm of trillions of cellular organisms. These bacteria break down the remaining tough fibers and synthesize vitamins. They are active partners in nutrient absorption and immune system maintenance. As the microbes do their work, the muscular walls of the colon act like a biological sponge, suctioning the remaining water out of the paste and hardening the waste into stool. Between the vast surface area of the small intestine and the microbial workforce in the colon, the lower tract functions as an exhaustive extraction facility, squeezing every usable drop of fuel from the material before disposal. Roughly 36 hours after that initial bite, the fully processed waste reaches the rectum, a straight 8-inch final chamber. The walls of this chamber are lined with a sensory network, engineered to detect the accumulation of solid mass or expanding gas. This vector graphic tracks the communication that happens next. A signal travels from the pelvis to the brain, translating biological pressure into the conscious realization that you need to find a bathroom. If the timing is wrong, the body deploys a failsafe. Specialized muscles called internal and external sphincters contract, both involuntarily and voluntarily, to secure the waste and delay the exit. When the environment is appropriate, the brain gives the all clear. The sensors calm, the sphincter muscles relax, and the body expels the remaining byproducts. We rarely think about the actual mechanics of a meal, but by taking a single bite, we fuel a sequence of biological interactions that convert yesterday's meals into today's survival.